Hello, I am Clara Valpo from Biomimetic Chromatography.
My name is Derek Munsterman. I'm a second-year graduate student in Oregon State University in Dr. Jennifer Fields' lab.
Yes, and Derek has visited us because he wants to learn how to use IAM chromatography for phospholipid binding measurements and predict toxicity of certain compounds.
Correct. So these certain compounds, or Dr. Jennifer Fields' group, specifically studies PFAS, or per and poly-fluoroalkyl substances. These are substances that are highly toxic, they're an environmental contaminant, they have very long half-lives, and they've been dubbed forever chemicals. So we are interested on how these chemicals bind to proteins and phospholipids and try to understand how they accumulate in the body.
Yes, and we now introduce this IAM column into our HPLC. IAM stands for immobilized artificial membrane, and this is a chemically bonded phosphatidylcholine on silica phase. And the retention time of compounds will reveal for us how strongly the compound binds to these phospholipids. And we published a few papers about how to use this measured phospholipid binding and albumin binding to predict in vivo distribution and various toxicity, even herb toxicity, phospholipidosis, and now we are also curious what is the toxicity of compounds and how we can model this by this HPLC to the environment. So let's put the column into the HPLC. This column is manufactured by Regis IAM phosphatidylcholine for drug discovery purposes, and we are running with an open purge pH 7.4 mobile phase. And we shall equilibrate our column there, and the computer which controls the instrument, we already set up the run. With a gradient, we use acetonitrile gradient, short gradient, and then we inject a standard set of compounds which cover a wide range of phospholipid binding from very weak to very strong, and then we measure the retention time of this binding, and we use this to calibrate our column and system on the day, so we can convert the gradient retention time to binding. Yes, let's close it because we're measuring an equilibrium constant with the retention time. It should be thermostated with control. So now, shall we show the wire? Yes, here is the injector, and this is the IAM test mix, which contains a homolog series, acetophenone homolog series up to octanophenone. And this is for our calibration, and then we can run our samples, and we shall turn the gradient retention time to a phospholipid binding. So let's start the system when it is ready. Oh no, we first have to close the purge valve and wait a few minutes to equilibrate the column with the pH 7.4 ammonium acetate mobile phase. I can start now because we always start running a few blank gradients, which is prepared by the solvent of the samples. So we have run our standards, which are, here you can see the chromatograms, which are a homolog series from acetophenone to octanophenone, and we have got two polar compounds, drug molecules, what we use. So now we have to calculate the so-called chi-IAM values, which is the measure of phospholipid binding, and it approximates the acetonitrile concentration when the peaks eluted from the column. And the higher the value, it means the compound partitioned into phospholipids much more, and the binding is stronger. So we are very happy with this nice chromatogram. So Derek now will enter and check whether enter the retention times and check whether the retention time will give us a straight line with the chi IAM values of the standards for which we already determined before the chi IAM values using isopropyl measurements. So we know that octanophenol will always elute with 49.4% acetonitrile. So we have to now check that what was the retention time, and it seems it was 5 minutes, 5.05 minutes. So we nicely now enter the retention times and plot against the predefined child values. Yeah. And you can see nicely that straight line is forming on the floor. Acetonolide and paracetamolide, two more polar, and these are known drugs actually, and they are not toxic and they don't bind to iron. Yes. Strongly. So here we are. So now we can see we have a beautiful straight line, and what we need is the slope and intercept of the straight line. So when we have a compound, these potential toxic compounds elute, let's say 3.5 minutes, what will be the chi IAM value, which represents the phospholipid